You wake before the alarm, not because of a sound, but because the room feels wrong. The walls are still there, the window is still there, your hands are still your hands, yet the morning light has changed, falling across the floor in a pale violet shade no human city has ever known. You stand, and even that simple movement feels unfamiliar. Your body answers a little too slowly. The air tastes faintly metallic. Outside, the street is quiet, as if every car, every bird, every distant voice has paused to listen. Then you look up. The sky is no longer the sky of Earth. A vast, unfamiliar world hangs above the horizon, not as a distant point of light, but as the planet beneath your feet, reflected in every altered cloud, every strange wind, every breath you take. Earth, the one constant behind every human life, has been replaced by another rocky planet in the same place around the sun. The cities remain, the memories remain, but the rules beneath them have shifted. This is not a story about magic or a simple explosion in space. It is a thought experiment built from real planetary science. Worlds differ in mass, gravity, air pressure, rotation, magnetic fields, oceans, seasons, and chemistry. Even a planet close enough to support human life could feel deeply hostile at first, not because it hates us, but because it was not shaped around our bodies, our crops, or our fragile machines. A slightly heavier world could turn stairs into obstacles. A thinner atmosphere could make every breath feel unfinished. A longer day could overheat the land and stretch the night into cold, silent hours. A missing moon could change tides, darkness, and the rhythm of coastal life. The question is not only whether humanity could survive, it is what survival would feel like. How would families wake up on the first morning? How would hospitals, farms, airports, power grids, and cities respond when the planet itself no longer matches the assumptions they were built for? How would children grow up under a sky their parents still feared? And how long would it take before the impossible became ordinary? To explore this, we will move slowly, step by step, from the first strange minutes to the first night, from the breaking of familiar weather to the reshaping of food, water, shelter, and memory. We will stay close to the human experience while keeping our feet on plausible science. If you enjoy quiet journeys through Earth, space, and the fragile conditions that make life possible, you can like this video, subscribe, and write in the comments where you are watching from tonight. It is always strange to imagine so many people in so many rooms looking up at the same question. Now, let the light fade a little. Breathe in slowly. Breathe out. Let the modern world grow distant and enter a softer, stranger Earth that is no longer Earth at all. The darkness behind your eyelids is still familiar, but the world waiting beyond it is not. The first thing you notice is not the planet in the sky, or the changed horizon, or even the silence outside the window. It is the small betrayal of your own body. Your chest rises with a breath that feels almost normal, then hesitates, as if the air has a different weight inside it. Your fingers press against the blanket, and the fabric seems ordinary, yet the movement of your hand has become strange. A cup on the bedside table trembles, making a tiny sound that should not feel frightening. But the oldest part of your mind understands before language does that the ground beneath you is no longer the ground it was yesterday. You sit up slowly. The room tilts, not because it is moving, but because your inner ear is comparing the new world to the memory of the old one. Balance is a quiet contract between your body and the planet. Every step you have ever taken has depended on gravity pulling you downward with a strength so constant you never had to notice it. Now that contract has been altered by a small amount, and a small amount is enough. If this replacement world is only slightly more massive, your legs feel heavier before you even stand. If it is slightly less massive, your movements become too light, too loose, almost dreamlike. Either way, you are suddenly aware that walking is not simple. It is a lifelong negotiation with a planet. Outside, the light continues to gather. It does not brighten the room in the usual way. It enters like a filtered memory of daylight, pale and tinted, touching the edges of furniture with a color that makes everything look borrowed. You cross the room and reach the window. For a second, the street below seems normal. Parked cars, balconies, the dark rectangles of neighboring windows, a traffic light changing from red to green for no one. Then your eyes rise above the roofs, and the feeling of normality collapses. The sky is wrong. It is not wrong in one dramatic, simple way. It is wrong in many quiet ways at once. The blue, you know, has been diluted with violet and ash. The clouds are stretched into unfamiliar layers, thinner in some places, swollen in others, their undersides lit by a faint copper glow. Near the horizon, the air seems thicker, as if the city is sitting inside a glass bowl filled with colored dust. The sun is present, but its light reaches you through a new atmosphere, scattered by new mixtures of gases, droplets, and particles. Even if the sun itself has not changed, the world between you and the sun has, and that is enough to change the face of morning. Across the city, curtains open. People step onto balconies. Some simply stand with one hand on the window frame, unable to decide whether to call someone or keep staring. In moments of true uncertainty, panic does not always arrive first. Often there is a pause, a silence in which the brain searches desperately for an ordinary explanation. But no explanation fits the size of the sky. Then the messages begin. People across continents are seeing the same changed light, the same strange atmospheric color, the same unfamiliar motion of clouds, the same impossible sense that the entire planet has been moved without their permission. The first global fact of this new morning is not a government statement or a scientific measurement. It is a shared human sentence, repeated in countless languages. Do you see it too? The sky has always been more than empty space above us. It is the ceiling of human memory. It is where storms announce themselves, where sailors once read direction, where farmers watched for rain, where children learned that day follows night and night follows day. The color of the sky is one of the deepest forms of reassurance on Earth, because it tells us, without words, that the atmosphere is still there, that light is still behaving as expected, that home is still home. When that color changes, the fear is not intellectual, it is ancient. It says that shelter may not be enough, because the change is not outside the house, it is above everything. Cars start, then stop. Drivers sit with doors half open, looking upward. A bus pulls to the side of the road because the driver cannot continue pretending the route still matters. On the pavement, people gather in small clusters, the way humans have gathered around fires, wells, and danger for thousands of years. A man points toward the eastern sky, but there is nothing precise to point at. only the impossible totality of the morning. A woman tries to call her mother, fails, tries again, and finally sends a voice message that says almost nothing except, "Breathe, breathe, stay inside." Animals react before the news does. Dogs bark from apartments, then fall into uneasy whining. Pigeons rise from a rooftop in a broken wave, circle once, and land again, as if the air has not given them the answer they expected. A cat refuses to cross an open balcony, crouching low, pupils wide. Insects that should be invisible at this hour collect near lights that no longer seem to guide them properly. Many animals depend on cues humans barely notice: pressure, light angle, magnetic direction, scent carried by humidity, vibrations in the ground. They do not need to understand a planetary replacement to feel that the pattern has been broken. Inside the first laboratories, observatories, and emergency centers, instruments are already telling a stranger story than any rumor could. Barometers show pressure values that may still be survivable, but not exactly Earth normal. Magnetometers record a field that might be weaker, stronger, tilted, or unstable compared with yesterday's familiar shield. Weather satellites, if they remain functional and correctly positioned, send back images that no longer match old maps in any meaningful way. The coastlines may still be where human memory placed them in this thought experiment, because the human world has been carried across with its cities and roads, but the atmosphere around it is governed by another planet's properties. Scientists do not yet know the full truth. They only know that the old assumptions are failing one after another. A replacement planet in the same orbit around the Sun sounds simple when described in a sentence. But a planet is not merely a ball of rock underfoot. It is a complete system. Its mass determines gravity. Its radius shapes how strong that gravity feels at the surface. Its atmosphere filters light, stores heat, moves weather, and presses against lungs. Its rotation sets the length of the day. Its axial tilt governs the rhythm of seasons. Its oceans carry heat. Its magnetic field helps protect the upper atmosphere from the solar wind. Its moon, if it has one, pulls at the seas and brightens the night. Change any one of these, and life notices. Change many at once, and civilization begins its first day as a guest in a house built for someone else. By mid-morning, people are no longer only looking at the sky. They are testing themselves. They walk down hallways. They lift objects. They climb stairs. They pour water and watch how it falls. They jump a few centimeters from the floor, ashamed of how frightened they are by such a childish experiment. In apartments, offices, schools, and hospitals, the same discovery repeats. The human body is a measuring instrument, and it is reporting a change. If gravity is stronger, the world becomes exhausting before it becomes deadly. A backpack seems filled with books, even when it is empty. A child who usually runs down the corridor slows and asks to be carried. Elderly people grip railings with both hands. Nurses moving between beds feel the strain in their calves and backs long before any official announcement uses the word gravity. Elevators still rise, but motors designed for one load now work closer to their limits. Warehouse shelves hold, but forklifts strain. Every bridge, crane, tower, and high-rise was designed with safety margins, but also with expectations. The replacement world presses on those expectations. If gravity is weaker, the fear is different. People feel briefly powerful, then clumsy. A step carries the body farther than intended. A door opened with ordinary force swings too fast. A glass dropped from a table falls more slowly, giving the mind a fraction of extra time to dread the sound. Children may laugh at first because lower gravity makes movement feel playful, but playfulness fades when adults begin to fall in unfamiliar ways, when cars handle strangely, when emergency workers discover that equipment no longer behaves with the muscle memory they trust. Low gravity does not feel like freedom for long. It feels like the world has become less committed to holding you. Human balance depends on gravity being reliable. The vestibular system in the inner ear senses motion and orientation. Muscles and joints report pressure. Eyes compare the horizon with what the body feels. When these signals disagree, nausea and vertigo can follow. On the first day, hospitals receive people who are not injured in any dramatic sense, but cannot stand without fear. Some are simply overwhelmed by the sensation that their body is no longer tuned to the planet. Doctors can treat symptoms, but the cause is everywhere. The waiting room, the ambulance bay, the hospital floor, the doctor's own tired legs are all part of the same experiment. Stairs become one of the first symbols of the new world. They are ordinary, everywhere, almost invisible in daily life, yet they reveal gravity more honestly than any speech. In apartment blocks, people descending to the street move slowly, one hand sliding along the rail. Parents carry infants against their chests and realize that even love has weight. In office towers, evacuation plans written for fires and earthquakes suddenly meet a stranger problem. How long does it take a building to empty when everyone's body has become uncertain? The answer varies from place to place, depending on the strength of the new gravity, but the deeper truth is universal. Modern life assumes that ordinary movement is easy. On the wrong planet, ordinary movement becomes a negotiation. By late morning, the first emergency broadcasts ask people to remain calm, stay indoors if possible, avoid unnecessary travel, check on vulnerable neighbors, and conserve medical supplies. The language is familiar, because institutions often reach for familiar sentences when facing unfamiliar dangers. But behind the calm voices, authorities are trying to understand a problem no emergency manual was written to contain. This is not a hurricane, although weather may come. It is not an earthquake, although structures may be stressed. It is not a pandemic, although hospitals may fill. The hazard is planetary. The hazard is the background condition of life. Then comes the breath. At first, many people do not notice the air clearly. Fear changes breathing by itself. A racing heart can make any atmosphere feel thin. But over hours, patterns emerge. Some people feel lightheaded after climbing stairs. Others develop headaches. Some describe the air as heavy, damp, or strangely sharp. In this plausible replacement world, the atmosphere remains broadly breathable. Otherwise, the story would end too quickly. But breathable is not the same as familiar. Human lungs evolved within a narrow range of pressure, oxygen concentration, carbon dioxide levels, humidity, and temperature. A small shift can be survivable while still changing how every hour feels. Air pressure matters because breathing is not simply pulling oxygen into the body. Oxygen must move from the lungs into the blood, and that movement depends partly on partial pressure, the effective pressure of oxygen in the air. At high altitude on Earth, where pressure is lower, People can struggle even when the percentage of oxygen remains similar. On a planet with a thinner atmosphere, sea-level cities might feel like mountain towns. Some bodies adapt, some do not. People with heart or lung disease become vulnerable. Newborns need careful monitoring. Athletes who once trusted their stamina suddenly slow down, confused by a fatigue that feels personal but is planetary. A denser atmosphere brings other problems. It may hold heat differently, carry sound differently, and make weather more forceful. Breathing could feel easier in one sense and oppressive in another, especially if humidity is high or carbon dioxide levels are elevated beyond what humans are used to. Too much carbon dioxide, even without an immediate lack of oxygen, can cause headaches, drowsiness, confusion, and a sense of air hunger. Buildings designed for earth ventilation now become critical machines. Air conditioners, filters, fans, sealed windows, hospital oxygen systems, subway airflow, airplane cabins, all were created within assumptions that may no longer be exact. In pharmacies, shelves empty quickly. The fear of bad air is among the oldest fears because it cannot be seen directly. You can close a door against an animal. You can climb away from water, but air enters you, whether you trust it or not. Every breath is an act of surrender to the atmosphere. On the first afternoon, millions of people become aware of that surrender. Schools face impossible choices. Some children are already in classrooms when the seriousness becomes undeniable. Teachers lower blinds, move students away from windows, and try to sound calm. Children ask better questions than adults expect. Is the sun still our sun? Can we go outside? Is the moon gone? Are we going to float away? The answers must be simple, and none of them are satisfying. A teacher may explain that gravity is still here, that air is still here, that parents are coming, but the children can read faces. They know when adults are speaking to comfort themselves as much as anyone else. In homes, families begin assembling small islands of safety, water bottles on the table, flashlights, blankets, charged phones, a radio found in a drawer, food counted without admitting it is being counted. The rituals of preparation are soothing because they give the hands something to do. Human beings are tool makers, and in moments of uncertainty, arranging tools becomes a prayer without words. Yet the scale of the change makes ordinary preparation feel fragile. A storm kit can help for a storm. What kit is there for waking up on another planet? The outside world keeps offering details. Sound travels differently if air density has changed. Sirens may seem slightly altered, their pitch and distance harder to judge. Wind pushes against trees in an unfamiliar way. Smoke from a chimney rises too slowly or too sharply. A plastic bag skitters along the street, then lifts higher than expected in a gust. These small observations matter because they show that the change is not symbolic, it is physical. The new planet is touching every object at once. By afternoon, the sun has crossed a portion of the sky, and the next great uncertainty becomes visible. Time itself may not be moving wrong, but the planet's rotation may be. A day is not a universal constant. It is the time a world takes to turn once under its star. Earth's roughly 24-hour day has shaped human biology so deeply that we build our cities, meals, work, sleep, and prayers around it. If the replacement planet turns more slowly, daylight lingers too long. Streets heat beyond expectation. Shadows move lazily. People keep checking clocks because the sky refuses to match the hour. If it turns faster, evening arrives too soon, cutting the day into unfamiliar pieces, making the body feel as if it is always late. The circadian rhythm is one of the quiet foundations of life. Inside the brain, a small biological clock responds to light and darkness, guiding sleep, hormones, temperature, alertness, and hunger. On Earth, this clock can adjust within limits, as travelers know when crossing time zones. But a planet with a significantly different day length would create something deeper than jet lag. It would ask every living body to renegotiate time. Some people would cling to 24-hour schedules using artificial light. Others would follow the new sunrise and sunset. Factories, hospitals, farms, and communications networks would debate which time is real, the time of human biology or the time of the sky. The first day, therefore, becomes a measurement. People watch the sun with the helpless attention of ancient astronomers. Shadows on walls become instruments. Scientists calculate rotational speed from observations, comparing the sun's apparent movement with yesterday's models, if yesterday can still be used as a reference. The result may not be known immediately, but the feeling arrives early. The sky is not keeping human appointments anymore. Plants notice too. Leaves open and close according to internal rhythms shaped by light. Flowers respond to day length. Crops use seasonal and daily cues to grow, bloom, and rest. On the first day, the full consequences are not yet visible, but farmers and botanists feel the future approaching. A field can survive one strange afternoon. A harvest cannot survive months of confusion without adaptation. In greenhouses, lamps become artificial suns, and timers become acts of defiance against the new rotation. Meanwhile, the oceans begin to speak in their own slow language. For those far inland, the sea may feel distant, almost irrelevant compared with breathing and gravity, but the ocean is one of the great regulators of a planet. It stores heat, feeds weather, shapes coastlines, and, on Earth, responds to the pull of the moon and sun through tides. If the replacement world has no moon like ours, or a moon of different mass and distance, the tides change. If gravity differs, water finds a new relationship with basins, shores, and slopes. If rotation differs, currents may shift over time. The first day along the coast is a day of watching water with fear. In harbors, tide gauges show behavior that does not match predictions. Boats tug at lines in unfamiliar rhythms. Mudflats appear at the wrong hour, or fail to appear. Waves may not be monstrous, because not every planetary change produces instant cinematic destruction. The more unsettling possibility is subtler. The sea becomes unpredictable. Fishermen who know the water by smell, color, and timing stand on docks and realize their knowledge has become incomplete. Ports built around schedules of tide and weather hesitate. Coastal trains stop, beaches empty. People who came to look at the strange sky back away when the water withdraws farther than expected, exposing rocks and sand that should have remained hidden. The moon, if absent or altered, becomes an emotional loss as well as a physical one. Humans have lived under its changing face for all of recorded history and far beyond it. It has lit paths, guided calendars, inspired myths, and pulled the oceans with steady patience. If the new planet's night has no familiar moon, then the first evening will not merely be darker, it will feel abandoned. If there is another moon, larger, smaller, faster, or colored by the new atmosphere, it may be beautiful. But beauty does not immediately comfort those who are grieving the familiar. As the day stretches or shortens, animals continue to provide uneasy evidence. Migratory birds depend partly on celestial and magnetic cues. Sea turtles, insects, fish, and many mammals respond to light, temperature, tides, and geomagnetic information. A changed magnetic field could disorient species that navigate across long distances. A changed atmosphere could alter scent trails. A changed day length could disrupt feeding and sleeping patterns. On farms, livestock become restless because their routines have been broken by human fear and planetary change together. Cows wait for milking at the wrong-feeling hour. Chickens return to roost according to a light that no longer matches the clock. Bees, if they fly, may encounter flowers responding uncertainly to unfamiliar light. The silence of some animals is worse than noise. In many places on Earth, humans are used to a background texture of life. Birds, insects, dogs, wind moving through leaves. When that texture thins, even city dwellers notice. A quiet street after a snowfall can feel peaceful because the cause is known. A quiet street under a violet sky, with animals hidden and people whispering, feels like the world is holding its breath. This is another primal fear. Not the fear of being attacked, but the fear that the living world has withdrawn its confidence. Late in the afternoon, official science begins to speak more clearly, though still cautiously. The replacement planet appears to occupy Earth's orbital distance from the Sun, or close enough that solar energy has not instantly rendered the surface uninhabitable. It appears rocky. It has an atmosphere that human beings can survive, at least for the moment. It may possess oceans or bodies of water, though their chemistry and distribution require testing. Gravity is measurable now. Pressure is measurable. Radiation levels are being checked. The magnetic field is being mapped. No serious scientist claims to understand how the replacement occurred, because that mechanism belongs to the impossible premise of the thought experiment. But once the premise is granted, the consequences can be studied with real physics. This distinction matters. The event itself may be beyond known science, but the aftermath is not pure fantasy. Planets truly do vary. Mars has weaker gravity and a thin atmosphere. Venus has crushing pressure and extreme heat. Titan has a thick, nitrogen-rich atmosphere, but freezing temperatures. Exoplanets discovered around other stars show that rocky worlds can differ widely in size, density, orbit, and likely climate. Earth is not the default planet. It is one outcome among many. Human life is adapted not to a planet in general, but to this planet in particular, with its specific air, water, gravity, chemistry, and timing. The replacement world reveals the precision of that dependence by disturbing it. The psychological effect deepens as people understand that the change is not local. There is no unaffected country to send help from, no distant, safe continent where the sky remains blue. Every nation is inside the same experiment, though not equally harmed. Some regions may find the new air easier to breathe because of elevation or humidity. Some coastlines may be more threatened by altered tides. Some crops may tolerate the new light better than others. Some buildings may handle gravity changes well, while others require evacuation. As always, a global event becomes local through geography, wealth, infrastructure, and chance. In crowded cities, the fear of being trapped grows. Elevators are avoided. Subways feel both protective and dangerous. Tunnels offer shelter from the sky, but also concentrate people and depend on ventilation. Roads fill not only with cars leaving, but with cars whose drivers do not know where leaving would mean. The primal urge is to move, to find higher ground, lower ground,
family, open space, enclosed space, any place that feels safer than the current one. Yet, when the planet itself has changed, direction loses its promise. North is not comfort. Distance is not escape. Emergency workers become the first visible guardians of order. Paramedics answer calls from people who cannot breathe, people who have fallen, people having panic attacks, people injured in traffic, people who simply need to hear another human voice. Firefighters inspect buildings. Police manage intersections where signals function, but attention does not. Utility crews monitor power stations, water systems, communication towers, and pipelines. Their work is practical, but also symbolic. Every repaired line says that civilization is still trying to continue. Every functioning streetlight says the old world has not entirely dissolved. Power grids face an uncertain evening.
Demand rises as people seal themselves indoors, run filters, charge devices, heat or cool rooms, and keep lights on against the unfamiliar sky. Renewable systems respond differently depending on weather and daylight. Solar panels may still work, but atmospheric color, dust, cloud cover, and day length affect output. Wind turbines may face altered wind patterns and air density. Thermal plants require cooling water and supply chains. Nuclear plants are built with layers of safety, but they too depend on trained crews, stable grids, and predictable environmental conditions. The first day is not necessarily a blackout, but it is a warning that energy is not separate from the planet. It is a conversation with air, water, heat, and time. Water systems also come under scrutiny. Taps may still run because pipes and reservoirs do not instantly vanish, but water quality depends on treatment plants, pressure systems, electricity, chemical supplies, microbial conditions, and source stability. Heavy rains, changed evaporation, altered river flow, or soil chemistry could threaten future supplies. On the first day, authorities tell people not to waste water. Many obey because the request feels reasonable. Others fill bathtubs and containers because fear is faster than trust. The sound of running taps becomes one of the day's private soundtracks, ordinary and ominous at once. In hospitals, the human consequences gather into patterns: respiratory distress, falls, anxiety, dehydration, exhaustion, premature labor induced by stress in some cases. Patients dependent on machines become a priority because any power instability could be fatal. Doctors and nurses are trained for crisis, but this crisis has no outer edge. A surgeon looking through a break room window sees the same alien light as every patient. A nurse calling home tells her family to stay inside, then returns to a ward where staying inside is not enough. Medicine becomes both science and reassurance. The white corridors, the monitors, the measured doses of oxygen, all are ways of saying that not everything has become unknowable. As evening approaches, the quality of light changes again. Sunset on the replacement planet is the first great spectacle after the shock of morning. Because atmospheric scattering depends on particles and gas composition, the colors may differ from any Earth sunset. The horizon could burn with deep orange under a violet upper sky, or fade into a copper haze, or dim rapidly if the atmosphere is thin and poor at scattering. People watch despite instructions to remain indoors. Humans are drawn to horizons because they promise explanation. On this evening, the horizon gives only beauty and fear mixed together. The sun lowers, shadows lengthen,
In streets and fields, people become aware that they are waiting for night, as if it were a test. Daylight, however strange, allowed observation. Night will remove information. It will ask the imagination to fill the spaces between sounds. It will reveal whether there is a familiar moon, whether stars are visible through the new air, whether temperatures fall gently or sharply, whether winds calm or strengthen. The first night on another planet is not merely darkness. It is the moment when humanity learns whether the dark still behaves like home. Temperature begins to change. If the atmosphere is thinner, heat may escape more quickly after sunset, and the cold may come with surprising speed. If the atmosphere is thicker, the day's heat may linger, turning rooms stagnant and uncomfortable. If humidity is different, sweat evaporates differently, skin feels different, breath condenses or fails to. These bodily details are small, but sleep depends on small details. A pillow too warm, air too dry, a distant siren, an unfamiliar wind, the knowledge that the sky outside is no longer Earth's sky. Each becomes part of wakefulness. Families prepare for night with gestures inherited from every age of human uncertainty. Doors locked, curtains drawn, children placed in the safest room, phones plugged in, shoes left nearby, a bag packed but not called a survival bag. Some people pray. Some refresh news feeds until networks slow. Some sit at windows because looking away feels worse. Some avoid windows because looking out feels like falling upward. In apartment buildings, neighbors who have never spoken knock gently on doors. Do you have water? Are you all right? Is anyone elderly here? Disaster often reveals the hidden
Village inside the modern city. Then the sky darkens enough for the stars. Perhaps they are not visible at first. A thicker or dustier atmosphere could hide many of them, leaving only the brightest points. Perhaps they appear sharper than ever through thinner air, cold and numerous, but arranged in familiar constellations if the planet remains at Earth's location and orientation relative to the distant stars. Yet even familiar stars may seem changed when framed by an unfamiliar atmosphere and an altered horizon, and if the replacement planet's axis is tilted differently, the nightly path of stars shifts. The ancient maps overhead no longer align perfectly with human expectation. For most of human history, the night sky was a calendar, a compass, and a storybook. Sailors crossed oceans with it, farmers marked seasons by it, cultures placed heroes, animals, gods, and warnings among the stars. Modern city lights have dimmed that relationship, but it has never disappeared. People still look for the moon instinctively. They still notice a bright planet near dusk. They still feel small under a clear sky. On this first night, smallness becomes overwhelming. The stars say that the universe is still there, but they also say that Earth was never guaranteed. If a new moon rises, crowds gather again despite fear. A moon too large would brighten the landscape with unfamiliar power, casting sharp shadows and pulling the ocean in ways scientists would urgently measure. A moon too small would feel insufficient, a lonely stone where a companion should be. No moon at all would leave the night darker than memory in places far from city lights. The absence would be physical along the coasts and emotional everywhere. Children would ask where it went. Adults would answer carefully, perhaps saying that this world may have its own sky and that we are still learning it. But privately, many would mourn the old moon as if it were a lost relative. The first night also changes sound.
Without the visual certainty of day, every noise becomes meaningful. Wind along buildings, pipes shifting with temperature, distant engines, helicopters or drones moving overhead, dogs barking, then stopping suddenly. In the countryside, the absence or alteration of insect song can make the darkness feel unfinished. In coastal towns, the sea may arrive at an unexpected hour, not violently, but with a rhythm that wakes people who have slept beside it for years. The world is not silent. It is speaking with an accent humanity has not learned. Sleep is rare, not absent because exhaustion eventually overpowers terror, but fractured. People drift off in chairs, on floors, beside radios, with lights on. Dreams mix old Earth with the new sky. A person dreams of walking under a blue morning and wakes to violet darkness at the window. Another dreams of falling slowly. Another dreams of a tide crossing a street without sound. The brain uses sleep to process memory, but the memory of this day is too large. It cannot yet be filed away as past. It is still happening. In command centers and research facilities, the work continues through the night. Data accumulates. Gravity values become more precise. Atmospheric composition is analyzed. Radiation levels are compared with safe exposure limits. Weather balloons, if launched, rise into a sky whose temperature and pressure layers must be newly understood. Ocean sensors record tides. Seismometers listen for internal activity, because a planet's geology matters too. A world with active plate tectonics, volcanism, or different crustal stresses could shape long-term habitability. But on the first night, even experts must prioritize immediate questions. Can people breathe safely? Will temperatures remain survivable? Are structures stable? Is drinking water safe? What happens at dawn? Dawn becomes the next promise. Humans have always trusted morning to return, even after war, grief, storm, and sickness. The first night on the replacement planet tests that trust. If the day is longer, dawn may arrive late, stretching fear beyond ordinary endurance. If the day is shorter, it may come too soon, before bodies have rested, making time feel broken. When light finally appears, it does not restore Earth. It simply proves that the new world has a rhythm of its own. And in that pale, returning light, people begin to understand something quieter and more frightening than the original shock. The first day was not an event that ended. It was
the opening of a relationship. The new planet is not passing by. It is not a visitor in the sky. It is the ground, the air, the weather, the weight of blood in the veins, the pressure against the skin, the shape of the sea, the clock behind the sun. Humanity has survived the first hours, but survival is only the beginning. Now, the deeper systems will start to reveal themselves: food, water, climate, health, shelter, distance, and the slow question of whether a civilization built for Earth can learn to live where Earth used to be. The second morning does not begin with surprise. It begins with inventory. In kitchens, people open cupboards and count cans: rice, pasta, flour, baby formula, medicine, batteries, candles, pet food. In supermarkets, the bright aisles look almost insulting in their normality, rows of products under fluorescent lights, while a foreign atmosphere presses against the roof. There is bread on shelves. There are apples in plastic crates. There are frozen meals behind glass doors. For a few hours, abundance remains visible, and that visibility calms people more than any official statement. Yet the comfort is fragile, because everyone can feel the same question forming beneath it.
These shelves were filled by yesterday's Earth. What will fill them tomorrow? Food is the first quiet test of the replacement planet. The human body can endure fear longer than hunger, but civilization cannot endure uncertainty about harvests for very long. Every city is an act of trust in distant fields. Every apartment block depends on soil, rain, insects, trucks, fuel, refrigeration, warehouses, markets, and farmers waking before dawn. On Earth, that system is already complex, but at least it rests on a familiar planet. Crops know the length of the day. Roots know the chemistry of the soil. Pollinators follow light and scent. Irrigation follows rivers and reservoirs shaped by known seasons. Now, the same seeds sit under a different sky, and the future of food becomes less a matter of storage than biology. In the first days, fields do not simply wither all at once. Plants are living systems, not fragile decorations. Many can survive stress, at least briefly. Leaves may turn, curl, slow their growth, close their stomata to conserve water, or adjust to light that carries a slightly different balance of wavelengths through the new atmosphere. Some crops might continue almost normally for a while, especially inside controlled greenhouses or in regions where temperature and pressure remain near familiar ranges. Others would suffer quickly. A plant does not need the entire world to become hostile. It only needs enough changes at once: a longer day, cooler nights, altered humidity, stressed soil microbes, fewer pollinators, or water arriving at the wrong time. Farmers become some of the most important observers on the planet. They notice before satellites do that the leaves are facing differently in the morning. They see that bees are late leaving their hives, or that they leave but circle as if the map inside them has blurred. They test irrigation lines, soil moisture, and greenhouse lamps. They walk between rows of wheat, corn, potatoes, rice, or vegetables with the calm, serious posture of people reading a language older than writing. In ordinary years, a farmer reads weather, pests, soil, and season. On the replacement planet, each field becomes a laboratory, and each farmer becomes a scientist of survival. The soil itself is not just dirt. Earth's productive ground is a living world made of minerals, water, air, fungi, bacteria, insects, decaying leaves, animal remains, and centuries of interaction. Roots do not feed alone. They trade with microbes, draw nutrients through fungal networks, and depend on chemical conditions that can be surprisingly narrow. If the replacement planet brings different dust, different rainfall, different acidity, or different trace elements into the surface environment, agriculture may face problems that are invisible at first. Crops could germinate and still fail. Leaves could look green while roots struggle below. A field could seem alive from the road and still be losing its future underground. This is why seed banks, greenhouses, and stored knowledge become sacred almost overnight. In cold vaults and research stations, collections of seeds are no longer symbols of biodiversity alone. They are options. Wheat varieties that tolerate drought, rice strains suited to different water levels,
Potatoes grown in cold climates, legumes able to cooperate with nitrogen-fixing bacteria, hardy grains once considered old-fashioned, all become valuable because no one knows which plant will match the new world best. The modern food system favors efficiency, but survival favors diversity. On the wrong planet, forgotten varieties may become the difference between famine and adaptation. Inside cities, people sense this without understanding the full science. They do not speak about stomata or soil microbiomes. They speak about prices. They speak about empty shelves.
they speak about whether trucks are still arriving. The first panic buying is not only selfishness, it is an animal response to a broken food horizon. Humans evolved in worlds where shortage killed, and the body remembers scarcity faster than the mind can reason about supply chains. A person may know that buying too much harms others and still feel the old command rising from the stomach: store, protect, hide, feed your children. Governments try to slow this instinct with rationing, price controls, delivery priorities, and public reassurance. The language of food changes. Luxury disappears from conversation. Calories, protein, shelf life, clean water, infant nutrition, and distribution become the central vocabulary. Restaurants close or simplify menus. Schools become feeding centers. Stadiums and community halls turn into warehouses. The question is no longer what people want to eat, but what can be grown, moved, stored, and shared without breaking trust. Every meal becomes slightly more conscious. Even a bowl of rice carries the weight of planetary uncertainty. Water follows close behind food, because water decides which maps still matter. On Earth, the geography of civilization is a geography of rivers, aquifers, monsoons, snowpacks, lakes, deltas, and predictable rain. Cities grow where water can be captured, moved, purified, and returned. Farms spread where moisture arrives in season or can be drawn from underground. But on another planet, even if lakes and seas remain, the pathways of water may change. Atmospheric pressure influences evaporation. Temperature controls snow and ice. Rotation and topography shape winds. Soil chemistry affects what water carries as it moves. The same river channel through a city may not behave like the same river for long. At first, taps still run in many places. This gives a dangerous sense of continuity. Pipes do not know the sky has changed. Pumps still push. Reservoirs still hold. Treatment plants still filter and disinfect. But every water system is connected to a larger cycle. If rain begins falling in different regions, if snow melts too early or never forms, if evaporation accelerates under longer daylight, if storms carry unfamiliar dust into reservoirs, then the water coming from a tap becomes a final step in a much larger uncertainty. Engineers begin testing constantly: turbidity, salinity, microbial content, acidity, mineral load, chemical contamination. Water has memory. It carries the story of the world it has crossed. In dry regions, fear arrives quickly. A reservoir that once represented months of security may begin to look small under an altered climate. In wet regions, too much water becomes its own danger. Drainage systems designed for old rainfall patterns can be overwhelmed if storms grow slower, heavier, or more frequent. Floodwater is not simply an inconvenience. It carries sewage, chemicals, fuel, soil, and disease. It enters basements where people have begun to shelter from the sky. It drowns electrical systems. It turns roads into boundaries. On Earth, cities already struggle with extreme rainfall. On the replacement planet, the old statistics no longer provide comfort. The politics of water becomes immediate, but not always dramatic. It begins with instructions: do not water lawns, boil water if advised, report leaks, limit showers, store only what you need. Then it becomes local negotiation. Which neighborhoods receive pressure first after a failure? Which farms are prioritized? Which industries shut down to preserve drinking supplies? Which regions send water and which keep it? Water creates moral choices because it is both personal and collective. A glass in a kitchen is intimate. A reservoir is political. A river is geographic destiny. As days pass into weeks, meteorologists face the humiliation and wonder of beginning again. Weather is chaotic, but it is not random. On Earth, prediction
depends on observations, equations, historical patterns, satellites, ocean measurements, pressure gradients, and models refined over decades. Those models are built for Earth's atmosphere and oceans. A replacement planet with different air density, rotation rate, heat storage, cloud behavior, or surface chemistry cannot simply be inserted into old software as a new forecast region. The equations of fluid motion remain real, but the parameters have changed. It is like knowing the grammar of a language and suddenly hearing a dialect no one has recorded. The first forecasts are cautious and short. Instead of confident weekly predictions, agencies offer broad ranges and warnings. Temperature may fall sharply after sunset in some regions. Winds may strengthen over open plains. Coastal fog may form where it never used to. Storm systems may stall. Clouds may build higher or lower depending on atmospheric structure. People who once joked about forecasts being wrong now understand that prediction is a form of civilization. A reliable weather forecast tells farmers when to plant, pilots when to fly, ships when to dock, crews when to repair power lines, parents whether children can walk to school. Without it, society becomes more hesitant, more local, more afraid of the sky. Storms on the replacement world do not need to be larger than earthly storms to become more dangerous. They only need to be unfamiliar. A moderate wind can damage structures if it blows from an unexpected direction for too long. Heavy rain can flood a city if drains are positioned for old patterns. Heat can become deadly if nights no longer cool enough for bodies to recover. Cold can break pipes in places that never protected them. Dust can reduce solar power, irritate lungs, contaminate reservoirs, and change the color of snow or ice. Weather is not a background event. It is the daily touch of planetary physics on human skin. In some regions, the atmosphere may create skies of haunting beauty. High clouds glowing long after sunset. Copper dawns over empty highways, pale halos around a strange moon, storm anvils rising like mountains in the distance. Beauty does not cancel fear. Sometimes it intensifies it, because the world becomes difficult to reject. People can hate a disaster. It is harder to hate a sky that terrifies them and still looks magnificent. The replacement planet begins to enter human emotion not only as threat, but as presence. The body keeps score of all this before the mind can organize it. After the first days, fatigue spreads. Some of it is physical. Gravity, air pressure, sleep disruption, temperature stress, and reduced movement alter the body's routines. In stronger gravity, muscles work harder, joints bear more, hearts pump blood against a slightly greater downward pull. Even a small increase could worsen existing conditions and make ordinary labor more tiring. In weaker gravity, muscles and bones may experience less load, which over long periods could lead to changes known from spaceflight research, though a mildly reduced surface gravity would not be the same as orbit. Human physiology is adaptable, but adaptation is not free. It spends energy, time, and comfort. Some of the fatigue is respiratory. If oxygen availability is reduced by lower pressure, people may sleep poorly, wake with headaches, or struggle during exertion. If carbon dioxide is higher, even modestly, rooms with poor ventilation become unpleasant. If dust or unfamiliar aerosols increase, asthma and irritation rise. The air does not have to be poisonous to become a daily burden.
It only has to be slightly less kind than Earth's air. Much of the fatigue, however, is psychological. The nervous system is built to detect uncertainty, and the replacement planet provides uncertainty without pause. The light is wrong in the morning. The weather cannot be trusted. The news changes hourly. Food and water require thought. Loved ones far away may be unreachable. Children ask questions that reopen fear. The body responds with vigilance. Elevated heart rate, shallow breathing, poor digestion, tense muscles, broken sleep. Over time, vigilance becomes exhaustion. The mind can understand that no immediate danger is present, while the body continues acting as if a predator is nearby. Doctors begin seeing a second wave of patients, not the first injuries, not the first respiratory cases, but the slow illnesses of adaptation. Insomnia, panic, dizziness, chest tightness without
Clear cardiac cause, high blood pressure, migraines, stress-related stomach problems, worsening of chronic diseases, missed medications because supply chains are interrupted. In every clinic, the boundary between physical and psychological becomes less useful because the planet is affecting both together. A patient says, "I cannot breathe," and it may be air pressure, anxiety, dust, carbon dioxide, heart strain, or all of them layered together. Public health changes its focus. The first goal was to keep people alive hour by hour. The next is to keep society functional week by week. Authorities promote ventilation guidelines, indoor air monitoring, sleep schedules, food distribution, hydration, mental health support, and protection for vulnerable groups. Communities organize check-ins for the elderly. Pharmacies coordinate refills. Hospitals create triage systems not only for emergencies, but for chronic continuity. Survival becomes less dramatic and more administrative. Forms, queues, delivery routes, generators, oxygen concentrators, water testing kits. Civilization reveals itself as the art of maintaining small systems under enormous pressure. Cities begin turning inward. The first instinct was to look up. The next is to seek cover. Modern cities were designed with the sky as decoration, not as an enemy. Glass towers celebrate light. Parks open to air. Streets invite movement. Balconies extend private life outward. But when light, air, temperature, and weather become uncertain, the most valuable spaces are often the most protected. Basements, subway stations, tunnels, underground parking garages, thick-walled schools, malls, hospitals, data centers, storage facilities. Places once considered secondary become the new skeleton of urban safety. The transformation is gradual at first. People sleep in lower rooms during heat, cold, or storms. Apartment residents gather in windowless corridors when winds rise. Metro platforms become temporary shelters with mats, chargers, water stations, medical tables, and quiet zones for children. Shopping centers become climate-controlled villages. Parking garages hold supplies. Office towers empty from the top floors downward if elevators are unreliable or if wind pressure makes height feel unsafe. The city does not collapse. It folds itself into its protected spaces. Architecture follows fear, and then fear becomes design. Engineers study which buildings perform best under the new gravity, temperature range, wind loads, and air demands. If the atmosphere is denser, wind exerts more force at the same speed, and structures may need reinforcement. If gravity is stronger, weight-bearing elements matter more, and elevators, cranes, and roofs face new stress. If temperatures swing widely, insulation and thermal mass become vital.
If radiation is higher due to a weaker magnetic field or thinner atmosphere, roofs and walls may need shielding. A home is no longer judged mainly by view, location, or beauty. It is judged by filtration, stability, energy efficiency, water access, and the ability to stay livable when the outside world changes suddenly. Windows become emotionally complicated. For generations, larger windows meant light, openness, wealth, and connection. On the replacement planet, glass is both comfort and vulnerability. It lets people watch the strange sky, but it also leaks heat, emits radiation if shielding is needed, breaks under storm stress, and reminds the mind of exposure. Some families cover windows with film, shutters, insulation, or improvised panels. Others refuse, needing to see outside to believe the world still exists. The argument over windows becomes a small argument over how to live after planetary loss. Protect yourself from the new world, or keep looking at it until it becomes familiar. Rural homes change differently. Farms cannot retreat fully underground because fields require attention. Barns, greenhouses, water tanks, seed stores, and animal shelters become fortified systems. Farmers build windbreaks, shade cloth, sealed storage, backup power, and controlled growing rooms. The old farmhouse, once a center of family and labor, becomes part of a wider survival machine. Weather stations appear beside barns. Soil sensors become as common as tractors. The farmer's almanac is replaced by live planetary data. Travel becomes one of the deepest fractures in daily life. At first, people assume movement will return once the shock passes. Airports will reopen.
Trains will run, highways will clear, ships will sail. But transportation is one of the most planet-dependent systems humans have ever built. Aviation depends on air density, temperature, wind, engine performance, runway length, fuel logistics, and reliable navigation. If the atmosphere is thinner, wings generate less lift at the same speed, requiring longer takeoff runs or lighter loads. If denser, drag increases and storms may behave differently. If dust or chemical aerosols are common, engines need inspection. Pilots trained on Earth weather now face skies whose patterns are still being learned. Air travel does not vanish everywhere, but it becomes cautious, limited, and precious. Test flights begin with instruments, not passengers. Military and research aircraft fly first, measuring air layers, turbulence, pressure, and visibility. Commercial aviation returns only where conditions permit and where runways, maintenance, and fuel are secure. The emotional consequence is immediate. Families separated by oceans or continents discover that distance has regained its ancient power. A video call can carry a face, but not a hand. A parent in one hemisphere and a child in another feel the replacement planet as a wall made of air, fuel, water, and risk. Roads remain essential, yet they too are changed. Vehicle engines rely on oxygen for combustion, cooling systems on temperature ranges, tires on road surfaces, drivers on visibility and predictable friction. Stronger gravity increases load and braking demands. Weaker gravity changes traction and handling. Dust storms reduce visibility. Heat softens roads. Cold cracks them. Flooding cuts low passages. Supply trucks become lifelines, and every route is assessed like an expedition. A highway map that once showed convenience now shows vulnerability. Bridges, tunnels, fuel points, elevation, flood zones, repair depots, places to shelter from weather. Rail may become more valuable in some regions because trains can move large quantities efficiently,
but rail lines are fixed and sensitive to heat, ground movement, flooding, and power supply. Ships still matter deeply, yet ports must relearn tides, currents, storms, and sediment. A container ship approaching harbor depends on timing, depth, tugboats, cranes, crews, and calm enough water. If tides shift unpredictably or storms behave strangely, the global shipping system slows. The world becomes larger without changing size. This enlargement of distance changes society. Local production becomes more important because imported goods are less certain. Repair becomes more valuable than replacement. Communities rediscover warehouses, workshops, mills, water towers, local farms, and skilled labor. The old global economy does not disappear overnight, but it loses some of its smoothness. The replacement planet adds friction to every movement. Friction changes culture. People become more careful with tools, more patient with repairs, more aware of where food, medicine, and fuel actually come from. A world that once promised instant delivery begins teaching the older lesson of dependence. As weeks turn toward months, the first true seasonal test approaches. Until a planet has carried people through a full cycle around the sun, no one really knows its temperament. Seasons depend mainly on axial tilt, the angle at which a planet leans as it orbits. Earth's tilt gives us familiar seasonal contrasts, softened and complicated by oceans, atmosphere, elevation, and geography. A replacement planet with a greater tilt could bring harsher seasonal extremes, long, intense summers in one hemisphere, deep and extended winters in the other. A smaller tilt could reduce seasonal variation, but disrupt ecosystems that depend on seasonal triggers. A different orbit would matter too, but in this thought experiment, the planet occupies Earth's place around the sun, keeping the broad solar distance that makes survival plausible. Even so, tilt, rotation, atmosphere, and oceans can rewrite the year. The first winter, or the first burning season, becomes a phrase people use with dread. In some regions, the danger is cold. A thinner atmosphere and longer nights could let heat escape rapidly, freezing pipes, killing crops, straining power grids, and forcing people into communal shelters. In other regions, the danger is heat. Longer daylight, denser air, altered cloud cover, or changed winds could create heat that does not release at night. Heat is especially
dangerous because it can be quiet. It does not break windows or roar like a storm. It enters the body, overwhelms cooling, and turns rooms into traps. Agriculture faces its first major deadline. Planting calendars are rewritten in pencil. Some farmers delay, waiting for better forecasts. Others plant multiple varieties at once, spreading risk. Greenhouses expand wherever materials allow. Indoor farming, often discussed before as an efficiency or urban innovation, becomes a survival strategy, though it requires energy, nutrients, water, and technical skill. Open fields remain necessary because feeding billions entirely indoors would be extraordinarily difficult. The future likely belongs to a patchwork: protected seed production, hardy outdoor crops, regional experimentation, rationing, and scientific breeding programs searching for resilience. The food chain beyond farms also trembles. Wild plants provide habitat and food for insects, birds, mammals, and soil organisms. If flowering times shift, pollinators may arrive too early or too late. If insects decline,
birds lose food. If vegetation changes, herbivores move or starve, and predators follow. Freshwater ecosystems respond to temperature, oxygen levels, flow, and chemistry. Oceans respond to heat, acidity, circulation, light penetration, and nutrient mixing. Human survival depends on managed systems, but those systems sit inside larger ecological webs. The replacement planet does not only challenge human technology, it challenges Earth life's timing. There is a deep loneliness in watching familiar species struggle. A city can accept rationing more easily than the disappearance of morning bird song. A farmer can calculate yield loss with discipline, then break down at the sight of dead bees outside a hive. A child can understand that adults are saving water, but not why the trees in the schoolyard leafed at the wrong time and then stopped. The ecological crisis becomes emotional because other living things make a world feel inhabited. Without them, survival feels like exile. Scientists and conservationists move quickly to preserve what can be preserved. Botanical gardens become emergency genetic libraries. Zoos become refuges for species that may not survive outside. Aquariums monitor water chemistry with new urgency. Frozen tissue samples, seed vaults, microbial collections, and breeding programs gain public attention. Before the replacement, conservation often meant saving nature from human pressure. Now it means saving Earth life from planetary mismatch. The ethical weight is enormous. Which species receive energy, space, and care when humans are rationing their own resources? Which ecosystems can be helped, and which must be watched as they change beyond recognition? Through all of this, culture begins adapting in subtle ways. People stop saying normal weather and start saying old weather. Children learn two sets of facts in school: what Earth was like and what this planet is doing now. News reports include atmospheric pressure the way they once included temperature. Public buildings display air quality, radiation levels if relevant, water status, and shelter capacity. The vocabulary of planetary science enters daily speech. Gravity becomes something a grandmother mentions when her knees hurt. Axial tilt becomes something a farmer curses. Partial pressure becomes something parents learn because their child sleeps better with supplemental oxygen. Concepts once reserved for textbooks become household realities. The emotional rhythm changes too. The first days were sharp with shock. The following weeks become heavy with endurance. There are moments of beauty and even tenderness, neighbors sharing water, children sleeping safely in underground stations, doctors applauded when power returns, farmers comparing notes across continents, scientists publishing open data so every region can learn faster. But beneath these moments is the knowledge that adaptation is not the same as rescue. No one is coming from the old Earth to restore the sky. The only path runs forward into understanding. As the first seasonal stresses arrive, another concern emerges from the edges of public attention: disease. Not a single new plague invented for drama, but the ordinary relationship between health and environment. Mosquitoes, ticks, rodents, flies, bacteria in water, molds in damp buildings, and respiratory infections in crowded shelters all depend on temperature,
Humidity, human density, and sanitation change those conditions, and familiar risks move into unfamiliar places. A warmer region may see insects active for longer. A flooded district may face contaminated water. A cold, crowded shelter may spread ordinary viruses with unusual efficiency. Public health workers, therefore, study maps that no longer behave like old maps. They watch not only hospitals, but standing water, waste systems, animal populations, and the movement of displaced people. Waste becomes a quiet frontier of survival. Modern cities hide waste so effectively that most people rarely think about it. Sewers carry it away. Trucks remove it at dawn. Treatment plants transform danger into manageable discharge. But if heavy rain floods sewage systems, if power failures interrupt pumping, if roads are blocked, or if people gather in temporary shelters without enough sanitation, waste returns from the invisible world into the visible one. This is one of the oldest threats to human settlement. Long before electricity or airplanes, cities survived or failed by their ability to separate drinking water from waste. On the replacement planet, that ancient lesson becomes modern again. Cleanliness is no longer merely comfort, it is a shield. Energy and sanitation begin to merge. A water plant needs power. A hospital needs power. Refrigerated food needs power. Communications need power. Shelters need heat, cooling, light, filtration, and charging stations. If the grid weakens, every other system feels it. Engineers start speaking of critical loads, microgrids, battery reserves, fuel rationing, and black start capability. These terms sound technical, but they describe something simple: keeping enough of the world alive long enough for repairs to matter. Neighborhoods with solar panels, batteries, wells, generators, or local heat networks become more resilient. Others depend on deliveries that may not come quickly. Inequality, already present before the replacement, becomes visible in the ability to stay warm, breathe clean air, and keep food from spoiling. The replacement planet does not distribute hardship fairly. Mountain communities may struggle with thinner air if pressure is lower. Coastal cities may face altered tides. Desert cities may become impossible without imported water. Cold regions may gain longer growing seasons in some cases, while tropical regions may face dangerous heat. Wealthy districts may seal buildings, install filters, and secure supplies. Poorer neighborhoods may live closer to industrial sites, flood zones, weak infrastructure, or overcrowded shelters. Planetary change is global, but suffering is always local. It follows pipes, roads, income, age, health, and political power. This creates a new moral geography. Maps shown on public broadcasts no longer highlight only borders. They show breathable zones, heat risk, water stability, crop outlook, shelter capacity, and transport reliability. Some areas are labeled temporarily unsuitable for outdoor labor. Others are marked as agricultural priority zones. Evacuation becomes less about fleeing one disaster than redistributing human presence across a transformed world. But movement is painful. People do not leave homes as pieces on a map. They leave graves, kitchens, schools, balconies, shops, gardens, familiar corners, and the invisible comfort of knowing where the morning light used to fall. The first large migrations begin quietly. A family sells nothing because money has lost clarity, packs what can be carried, and joins a convoy toward a region reported to have better water. A village near a coast moves inland after repeated tide anomalies. Workers from overheated cities are relocated to cooler industrial towns. Governments call these movements temporary because temporary is easier to accept. But many people understand that temporary can become history.
Human civilization has always followed livable conditions. Rivers, fertile plains, harbors, monsoon belts, grasslands, and trade winds shaped where people gathered. The replacement planet begins drawing a new human map. In the midst of movement, communication becomes a lifeline. Satellites may still function if their orbits remain stable in this thought experiment, but orbital systems depend on ground stations, power, timing, and the gravitational environment for which they were designed. Some satellites may require recalibration. Navigation systems may be less reliable until reference frames are
corrected. Radio communication, fiber networks, undersea cables, cell towers, and emergency broadcasts all become part of the effort to keep humanity emotionally connected while physically constrained. A message from a distant loved one can prevent panic as surely as food prevents hunger. Isolation is not only logistical, it is biological. Humans are social animals, and separation feels dangerous because, for most of our history, it was. Schools reopen in altered forms before many other institutions because children need routine and adults need hope. Lessons are shorter. Rooms are monitored for air quality. Outdoor play depends on daily conditions. Science classes become strangely immediate. Teachers explain why air pressure matters, while children feel it in their chests. They explain seasons while the class watches unfamiliar light move across the wall. History lessons include Earth not as a distant planet, but as the lost baseline of their parents' lives. Education becomes a way to prevent fear from turning into superstition. To name a thing is not to control it completely, but it makes the darkness less shapeless. Religions, philosophies, and private beliefs respond as well. Some people interpret the replacement as punishment, test, miracle, illusion, or cosmic accident. Others turn away from meaning and cling to measurement. Most live somewhere between, needing both data and comfort. Candles are lit under alien skies. Services are held in shelters. Songs are sung softly in subway stations. Scientists may dislike unsupported claims, but they also understand that humans cannot survive by information alone. A society needs explanations, but it also needs rituals that help grief move through the body. Over months, one of the strangest changes is the shifting definition of home. At first, home means the old apartment, the old street, the old town. Then, home begins to mean any room with safe air, clean water, reliable temperature, and people who know your name. Later, it may mean a settlement built for the replacement world from the ground up. Thicker walls, smaller windows, shared gardens under glass, water recycling, communal kitchens, clinics, workshops, schools, and observation towers that face the strange weather. Home becomes less a place inherited from the past and more a system maintained together. The psychological adaptation is uneven. Some people refuse the new sky for as long as they can, keeping curtains closed, playing old recordings of rain and birds, eating preserved foods from before the change on special days. Others become fascinated, learning the new constellations of weather, memorizing cloud types, volunteering for survey teams. Many move between grief and curiosity. This is not contradiction. It is how humans survive loss. We mourn what is gone, then slowly begin to study what remains. The replacement planet presses on the species not only as danger, but as a question. Can attention become a form of belonging? Even language starts to shift. People invent names for new winds, new colors of dawn, new illnesses of fatigue, new shelter routines, new kinds of weather anxiety. Children shorten technical terms into playground words. Farmers develop phrases for plant behavior no older generation had seen. Coastal communities name tides by temperament instead of calendar. Words are tools for living inside reality. When reality changes, language grows handles where fear used to be smooth. And beneath every new word is the same old effort to make the unknown small enough to touch. People whisper these words in kitchens and shelters, on farms, in hospitals, beside radios at night. Slowly, the planet becomes less unnamed, though not less powerful, and naming becomes the first fragile form of peace for everyone. By the time the first major season begins, humanity has already changed in ways that are difficult to measure. People walk more carefully. They waste less food. They notice clouds. They listen to weather reports with the attention once given to war news. They know the location of the nearest shelter. They understand which neighbors need help carrying water or medicine. They have learned that a planet is not scenery. It is infrastructure. It is the oldest infrastructure of all. And still, the new world is only beginning to reveal its deeper shape. Food systems have bent, but not fully broken. Water has become a map of power and mercy. Weather has become a language being learned in real time. Bodies have grown tired under altered air, altered weight, altered sleep. Cities have turned inward, becoming caves of light and machinery. Distance has widened. Seasons have approached like unknown animals at the edge of the fire. The next question rises quietly from all of this, not in laboratories alone, but in bedrooms, shelters, classrooms, farms, and coastal towns. If humans can endure the first transformation, what kind of world will they build afterward? And what kind of people will be born beneath a sky that never belonged to Earth? The people born after the first season do not inherit the shock in the same way. They inherit routines. They learn which doors seal properly, which shelters stay coolest through the long afternoon, which staircases are safest under the altered pull of gravity, which windows can be opened for a few minutes when the air is kind. For their parents, every rule is a compromise with loss. For them, it is simply how morning works. The new planet begins not as a catastrophe, but as a set of habits whispered into childhood. Check the sky before leaving. Carry water. Listen for the weather tone. Never ignore the pressure alarm. And if the horizon turns copper before noon, come home. This is how civilizations change, not always through one dramatic decision, but through repeated gestures, small enough to seem ordinary. A family sleeping closer to the center of a building, a school moving its playground indoors, a neighborhood sharing a greenhouse, a city painting old road signs with new evacuation colors. The replacement world does not ask humanity to adapt once. It asks every day in different ways until adaptation becomes culture. The age of shelters begins quietly. At first, shelter is an emergency word. It means subway platforms, reinforced basements, tunnels, storage halls, underground parking structures, and windowless rooms where people gather when the wind becomes uncertain or the temperature turns dangerous. But over time, shelter becomes architecture. It becomes planning. It becomes beauty of a different kind. Buildings are judged less by how much sky they display
and more by how gently they hold human life inside them. A good wall is not only strong, it filters, insulates, stores heat, resists pressure changes, protects against dust, and can be repaired with materials close at hand. On Earth, cities often reached upward, trying to touch the sky with glass. On the replacement planet, many begin reaching inward and downward. New neighborhoods are built partly into hillsides, under soil, behind thick outer shells, or around protected courtyards covered by transparent roofs. The goal is not to hide from the world forever, because humans still need light, movement, and contact with the outside. The goal is to make the outside negotiable. A door becomes a boundary between two climates. A greenhouse becomes a captured summer. A tunnel becomes a street that does not fear the wind. The most successful settlements are not bunkers in the old sense. They are living systems. Their roofs collect water when water can be trusted. Their walls carry pipes, cables, filters, and heat exchangers. Their lower floors hold clinics, workshops, seed stores, and community kitchens. Their upper levels, where conditions allow, keep observation rooms and quiet gardens facing the strange sky. Plants are placed where people can see them, because survival without green life feels too close to imprisonment. A single indoor tree in a public hall can become a meeting place, a memory, and a promise. Light becomes carefully designed. Too little natural light weakens the mind. Too much exposure can overheat rooms, waste energy, or let in harmful radiation if the planet's magnetic field or atmosphere offers less protection than Earth once did. Engineers, doctors, and architects work together in ways that once seemed specialized and separate. They measure sleep, mood, growth, vitamin levels, eye strain, plant health, and energy use. The window is no longer just a window. It is biology, comfort, risk, and memory held inside one pane. Some cities keep their old centers as monuments of exposure. Empty glass towers stand like frozen ambitions, reflecting violet dawns and copper storms. Not all are abandoned. Some are retrofitted with layered skins, external supports, shutters, and air systems. Others become weather stations, communication towers, or sealed archives. The skyline does not disappear, but its meaning changes. It
no longer says only wealth or progress. It says that humans once trusted the open air more easily. The new human world is built around maintenance. This is less glamorous than exploration, but more important. Filters must be replaced. Pumps must be repaired. Greenhouse seals must be checked. Water recycling systems must be cleaned. Soil cultures must be protected. Batteries must be monitored. Weather instruments must be calibrated. A settlement can be full of advanced technology and still depend on the patience of people who know how to tighten bolts, mend fabric, test valves, patch leaks, and notice the faint sound of a failing fan. The future belongs not only to inventors, but to caretakers. Children grow up inside this care. They know the sound of air systems the way earlier children knew the sound of rain on roofs. They sleep through low mechanical hums that would have kept their grandparents awake during the first anxious nights. They learn early that doors are not slammed, water is not wasted, and lights are not left burning without reason. These rules may seem severe, yet children have always grown within the rules of their environment. A child on a fishing coast learns tides. A child in a desert learns shade. A child in a mountain village learns thin air and steep paths. A child of the replacement planet learns thresholds.
Their bodies may also tell a quieter story. Human development responds to nutrition, activity, light, stress, and gravity. If surface gravity is modestly stronger, children build strength under greater load, but may face more strain and fatigue. If gravity is weaker, they may need designed exercise, weighted clothing, or movement routines to support bone and muscle development, just as astronauts require exercise to reduce the effects of weightlessness, though the surface of a planet is not the same as orbit. If the day length differs, schools may use artificial lighting to protect circadian rhythms. If natural sunlight is weaker, stronger, or filtered differently, health systems monitor growth and vitamin needs carefully. Biology becomes a shared responsibility. These children also inherit two worlds in language. Their parents say Earth, as if naming a person who died. Their teachers say Earth as a scientific baseline. In lessons, Earth is the planet where humans evolved, where air pressure, gravity, oceans, magnetic shielding, a large moon, plate tectonics, and climate patterns combined in a rare and generous balance. It is not described as perfect because Earth was never gentle everywhere. It had deserts, storms, ice ages, droughts, volcanoes, and extinctions. But it was the world that made us possible. That fact gives it an almost sacred gravity in memory. For the young, the old blue sky becomes an image before it becomes nostalgia. They see it in recordings, paintings, preserved films, and digital archives. They know that oceans once had familiar tides, that birds once migrated under known stars, that farmers once trusted seasons written into calendars generations old. But they do not feel the loss in their bones unless adults teach it to them. This creates a tenderness and a distance between generations. A mother may cry at the sound of an old summer thunderstorm recording. Her child may listen politely, then ask whether the storm was dangerous. The child can learn the fact of beauty, but not the full ache of remembering it. Museums change because memory changes. The most important exhibits are not only rare artifacts, but ordinary sensations. A room simulating Earth daylight, a chamber with the smell of rain on dry soil, a recording of insects on a warm evening, a projection of the moon rising over a familiar ocean, a floor calibrated to old Earth gravity where visitors can walk for a few minutes and feel the weight their ancestors took for granted. People enter these exhibits softly. Some laugh, some fall silent. Some elderly visitors close their eyes, not to see better, but to return. Archives become emotional infrastructure. Every family video taken before the replacement gains value. A picnic under a normal sky, a dog running through grass, traffic moving under ordinary clouds, snow falling under an atmosphere no one feared. The images are not scientifically important in a narrow sense, but they preserve the daily planet humans lost. Great disasters often turn private memory into public history. Here, the loss is so large that even the most boring footage becomes precious.
Shaky recording of rainwater flowing along a curb can become a relic. Yet, the new world is not only grief. Humans cannot live forever inside comparison. Slowly, the replacement planet offers its own forms of beauty. Dawn may have a layered violet glow that Earth never had. Winds may carve clouds into long, luminous bands. A strange moon, if one exists, may rise with a color that becomes beloved by children. Sheltered gardens may bloom under filtered light, and people may find that some flowers open more vividly in the new spectrum. The first generation may call these sights uncanny. The second may call them beautiful. The third, may call them home. Society reorganizes around those who can keep home functioning. Professions change in status. Before the replacement, wealth and attention often gathered around finance, entertainment, influence, and speed. Afterward, the most respected people may be water engineers, greenhouse farmers, soil microbiologists, doctors, atmospheric technicians, structural inspectors, electricians, logistics coordinators, emergency teachers, and repair crews. This does not mean ambition disappears. It means ambition is redirected toward continuity. The person who can restore airflow in a shelter during a heat wave becomes more important than someone who can merely speak well about the future. Politics changes too, because the basis of power changes. A government that cannot provide water, food distribution, healthcare, weather warnings, and credible information loses trust quickly. Borders still matter, but livability cuts across them. High ground, stable aquifers, fertile protected valleys, sheltered ports, reliable energy zones, and regions with manageable temperatures become strategic. Alliances form around resources and expertise. Data sharing becomes a form of diplomacy. A nation that hoards atmospheric models or seed research may protect itself briefly, but a planet does not respect borders. Weather crosses them. Dust crosses them. Disease crosses them. Hunger crosses them. Survival teaches a severe kind of cooperation. At the local level, community becomes more visible. Apartment blocks elect maintenance coordinators. Neighborhoods organize water rotations. Schools double as information setters. Farmers work directly with nearby towns. People learn the names of those who fix generators, deliver medicine, monitor air, and check on the old. This can be harsh because close communities can also exclude, judge, and compete. But the basic truth remains. On a difficult planet, isolation is expensive. Humans become safer when they are known. The old primal fear of being cast out returns in modern clothing. To lose access to a shelter, water network, medical system, or food cooperative can feel like exile from the tribe. Social trust becomes a survival resource. People become careful with reputation, promises, obligations, and usefulness. The replacement planet reminds modern humanity of something ancient. Belonging is not sentimental. For most of our species' history, belonging meant warmth, protection, shared food, warnings, care for children, and someone to notice if you did not return. Still, humans also need frontiers. Once the first settlements stabilize, exploration begins again. Not reckless exploration, but careful, instrumented, patient movement into the landscape beyond protected zones. Teams travel in sealed vehicles or reinforced suits depending on conditions. They carry air monitors, radiation badges if needed, water kits, soil samplers, drones, maps, medical packs, and repair tools. They move slowly because this planet punishes arrogance. An open plain may hide dust that irritates lungs. A valley may trap heavy gases or cold air. A coastline may seem calm until a tide arrives outside expectation. A beautiful lake may hold chemistry unsafe for drinking or irrigation. These expeditions become the new mythology of the age. Not conquest, not in the old careless sense, but reconnaissance. People watch live feeds from survey teams the way earlier generations watched moon landings or deep-sea dives. A rover crosses a plain where the light bends through unfamiliar haze. A drone rises above a ridge and reveals a basin filled with mist. A scientist kneels to test soil.
while the world waits to know whether anything can grow there. A small group reaches a high place and sees weather forming hundreds of kilometers away, an immense structure of cloud and shadow. The planet outside the
walls becomes visible, piece by piece. Mapping is an act of intimacy. To map a place is to say that fear has edges. Early maps of the replacement world include danger zones, pressure gradients, radiation measurements, wind corridors, flood basins, soil suitability, water sources, stable routes, and places where old infrastructure can be revived. Later maps include names. Names change everything. A ridge named after a lost city, a valley named for the first child born there, a greenhouse district named for the color of its morning light, a storm track named by the coastal people who learned its rhythm. The new world becomes less alien as language settles over it, but naming does not remove uncertainty. The planet remains larger than human knowledge. There are remote deserts where instruments fail, mountain ranges where weather behaves violently, seas whose currents are still being understood, ice fields forming or retreating in unexpected places, forests that survive in altered form, and dead zones where Earth life cannot easily root. Some landscapes are beautiful but unusable. Others look barren and become vital because they hold minerals, stable ground, or underground ice. Human hope learns to look carefully, not romantically. The question of Earth life becomes one of the deepest scientific and emotional projects. Humans are only one branch of a vast living system carried from the old world. The survival of crops matters first, because hunger is immediate. But beyond crops are pollinators, fungi, soil bacteria, plankton, forests, grasses, freshwater organisms, coral systems, if any oceans remain suitable, livestock, wild animals, and countless species with roles humans barely understand. Earth's biosphere is not a collection of independent objects. It is a network of exchanges. Gases, nutrients, energy, decay, reproduction, competition, cooperation. Move that network into altered conditions, and some links hold, while others break. Biologists approach the problem with humility. They know from Earth's history that life can be resilient. Microbes survive extremes. Plants colonize lava flows. Animals adapt to deserts, caves, polar seas, high mountains, and deep oceans. Evolution has filled Earth with experiments in endurance, but resilience is not immortality. Many species survive only within narrow ranges. A pollinator may need a flower at the right time. A fish may need water at the right temperature and oxygen level. A fungus may need a soil chemistry that no longer persists. A forest may survive one strange year and fail after repeated reproductive disruption. The future becomes a sorting process, not by moral worth, but by compatibility. Humans intervene because doing nothing would mean watching too much vanish. Protected biomes are constructed under domes, in valleys, underground farms, controlled parks, and sealed reserves. These are not perfect copies of Earth. They are lifeboats for selected pieces of it. Soil is maintained like a living treasure. Pollinators are bred and monitored. Seeds are rotated through growth cycles so they remain viable. Aquatic systems are carefully buffered. Animals are kept where space and ethics allow, though the demands are immense. Every preserved ecosystem requires energy, water, expertise, and attention. Conservation becomes active, intimate, and difficult. There are arguments. There must be.
Should resources go toward preserving species that cannot survive outside artificial habitats, or toward feeding people? Should large animals be maintained if their food demands are high? Should forests be recreated for emotional and ecological reasons, even if agriculture needs the land? Should extinct in the wild populations be kept alive indefinitely in controlled spaces? These questions existed on Earth before, but the replacement planet sharpens them. When the whole biosphere is under pressure, conservation is no longer a separate cause. It is part of the question of what humanity believes survival should mean. Some species surprise everyone. Hardy weeds thrive in cracks under the new light. Certain insects adapt to sheltered agriculture. Some fungi become crucial allies in damaged soils. Algae strains help produce oxygen, food supplements, or water treatment support in controlled systems. Generalist animals, the ones that lived close to humans before, may follow us into the new settlements. Rats, pigeons, sparrows, dogs, cats, insects, microbes, all the adaptable companions and
Pests of civilization. The new ecology of human zones becomes a strange mixture of deliberate preservation and accidental survival. Other losses are accepted slowly, painfully. A bird whose migration fails again and again. A tree that grows but no longer reproduces well. A coastal ecosystem transformed by changed tides and chemistry. A coral reef, if exposed to unsuitable temperatures or water conditions, fading beyond recovery. Extinction is not always a single moment. It can be a long thinning, a silence arriving over years. People mark these silences. They hold ceremonies for vanished species. They archive calls, feathers, seeds, images, and genetic samples. They teach children names of animals they may never see alive. Memory becomes part of ecology. As years pass, humans begin measuring time differently. At first, everyone keeps the old calendars because administration requires continuity. Birth records, contracts, histories, and personal identity depend on dates. But the sky insists on another rhythm. If the day is longer or shorter, if seasons arrive differently, if the new moon cycles do not match old months, then calendars become less natural and more symbolic. People live with two clocks, the inherited time of Earth and the practical time of the replacement planet. The creation of a new calendar is not just mathematics, it is grief management. Some want to preserve Earth time forever, arguing that humanity should not surrender the measure of its origin. Others argue that children need a calendar that fits the world they actually inhabit, with planting seasons, shelter cycles, storm periods, and daylight patterns named honestly. A compromise emerges in many places. The old Earth calendar remains for history, memory, and connection to the past. A planetary calendar grows for agriculture, school terms, public health, energy planning, and daily life. People learn to ask not only what day it is, but which time you mean. The day of replacement becomes the central anniversary. At first, it is marked with mourning, sirens, names of the dead, images of Earth, and readings from those who recorded the first morning. Later, as generations shift, it becomes more complex. It is still a day of loss, but also the beginning of the world known by the young. Public ceremonies hold both truths carefully. Lights are dimmed to remember the old sky. Then shelters, greenhouses, hospitals, farms, and water stations are honored because survival was built by ordinary labor. Children sing songs whose melodies borrow from old Earth music, but whose words describe new dawns. Personal milestones become double exposed. A person may say,
I was born 3 years before replacement, or I was born in the 5th long winter, or I was married under the first copper moon. Age itself can be counted by biological years, old Earth years, or planetary cycles. This sounds confusing, but human societies have always managed multiple calendars: religious, agricultural, civil, lunar, solar. Time is not only astronomy, it is culture deciding which cycles matter. The deeper shift is psychological. At some point, the question changes from how to restore the old world to how to live honorably in the new one. Not everyone accepts this at the same pace. Some movements remain devoted to preserving Earth identity above all else. Others embrace the replacement planet so strongly that they treat nostalgia as weakness. Most people do what humans usually do. They carry contradiction. They tell Earth stories while planting new crops. They mourn the moon while naming the new one. They teach children about oceans that once behaved differently, then send them to study the sea that actually touches their shores. Identity becomes layered. Humanity is still an Earth species, biologically, shaped by millions of years of evolution under Earth gravity, Earth air, Earth light, Earth microbes, Earth landscapes. But culture is faster than evolution. Within a few generations, people may speak, build, farm, sleep, travel, and imagine according to the replacement world. Their myths change. Their fears change. Their sense of beauty changes. A storm that terrified the first generation becomes a seasonal marker for the third. A shelter practice that once felt like emergency becomes tradition. The new planet enters lullabies. This is the strange mercy of adaptation. It prevents grief from remaining unbearable forever, but it also carries a second grief, the fear of forgetting.
Those who remember Earth may worry that acceptance is betrayal. If children laugh under a violet sky, does that mean the blue sky mattered less? If people celebrate a harvest in protected soil, does that mean old open fields are gone from the heart? The answer is gentler than fear allows. Love for the old world does not require hatred of the new one. Memory and belonging can share the same body. The scientific work becomes slower, more patient, and more philosophical as immediate survival stabilizes. In the beginning, researchers measured what could hurt people by sunset. Later, they begin asking what this world will become across decades. They drill cores into soil and ice, if ice exists, to understand how the replacement planet stores climate history. They send balloons through the atmosphere, then aircraft, then high-altitude observatories where conditions permit. They compare cloud formation, heat transport, radiation, ocean circulation, and the chemistry of rain. The work is urgent, but it also has the feeling of first science, the kind practiced by early naturalists who looked at coastlines, fossils, winds, and stars with the humility of people who knew that nature was larger than their categories. Astronomy changes as well. The stars remain distant, but the platform from which humans observe them is no longer the same. Telescopes must be recalibrated for the new atmosphere. Observatories may be moved to drier, higher, clearer regions. If the magnetic field differs, auroras may appear at unfamiliar latitudes, curtains of light trembling over places that never knew them before. These displays can be dangerous clues, signs of charged particles interacting with the upper atmosphere, but they are also breathtaking. People gather under protected glass to watch green, red, or violet veils move across the night.
Even fear can become wonder when it is slow enough to see. The space programs face a strange inheritance. Rockets designed for Earth gravity and atmosphere may no longer perform exactly as planned. Stronger gravity makes launch harder, demanding more fuel or smaller payloads. Weaker gravity eases ascent, but changes aerodynamic and structural assumptions. Air density affects drag and engine behavior. Launch sites must be re-evaluated. Yet, space becomes psychologically important because orbit offers perspective. The first images of the replacement planet from above are studied with reverence and pain. They show cloud bands, continents of settlement, altered coastlines, seas, deserts, ice, storms, and nights dotted by human light. For the first time, humanity sees its new home as a whole, and the sight is both alien and intimate. Art changes before law finishes changing. Painters try to capture the new color of noon. Musicians record the altered sound of wind through reinforced streets. Writers describe the first generation that never saw Earth. Children invent games around pressure alarms and indoor gardens. Films recreate the old blue sky with such precision that audiences weep. Other artists refuse nostalgia and celebrate the replacement world's severe beauty. The copper storms, the low shelter lights, the careful gardens, the sound of communities breathing through shared machines. Food culture becomes one of the gentlest forms of continuity. Recipes adapt to rationing, new crop varieties, preserved seeds, greenhouse vegetables, fermentation, and local substitutes. Families still gather around tables, even if the ingredients have changed. A grandmother teaches a child how a dish used to taste with herbs that no longer grow easily. A new version is made with greenhouse leaves and carefully measured spices. It is not the same, but it is eaten together, and therefore it becomes real. Cuisine has always been migration remembered through flavor. Now it becomes planetary migration remembered through the mouth. The religions of sky and earth absorb new images. Prayers once said under blue daylight are spoken under violet dawn. Blessings for harvests mention sealed soil beds and pollinator rooms. Mourning rites include the lost planet not as a god, but as the ground from which ancestors rose. Secular rituals grow beside spiritual ones. The annual testing of community shelters, the lighting of greenhouses during the darkest cycle, the reading of names from the first winter, the quiet hour when artificial lights are dimmed and recordings of earth rain are played. Ritual marks what must not be allowed to dissolve into routine.
There are also ruins, though not all are ancient. Places abandoned after the replacement become landscapes of the near past. Coastal neighborhoods left after tide changes, airports where runways cracked or no longer suited the air, glass business districts too costly to retrofit, suburbs that could not secure water. These sites are explored cautiously, sometimes reclaimed, sometimes preserved as warnings. They remind people that civilization is conditional. A city can be full of roads, signs, wires, and memories, and still become unsuitable if the planet withdraws a few basic permissions. In these ruins, plants may return in unexpected ways, not always the old native plants, and not always the desired ones, but hardy survivors finding cracks, moisture, shelter, and light. Mosses, grasses, fungi, shrubs, and opportunistic trees can turn abandoned concrete into experiments. Ecologists study them carefully because unplanned life often reveals possibilities planned systems miss. A weed in a ruined station
may show tolerance to new dust. A fungus in an old basement may help stabilize soil. A colony of insects nesting in a sheltered wall may become a pollination clue. The New World teaches through accidents as well as laboratories. The question of human evolution remains mostly distant because evolution works over many generations and culture changes much faster. Still, scientists consider the long horizon. If humans remain on this planet for thousands of years, selection pressures could shift subtly, especially if gravity, light, disease exposure, altitude patterns, or nutrition differ from Earth. More important in the near term is cultural and technological adaptation. Medicine, architecture, clothing, agriculture, and social organization buffer bodies from the full force of the environment. Humans may not quickly become a new species, but they become a new civilization. That distinction matters. Biology carries the past slowly. Culture answers the present at speed. As decades pass, the adults who remember the replacement grow old. They become quiet, living bridges. They are invited to schools, asked to describe blue sky, ordinary tides, easy travel, fresh rain, and the feeling of standing outside without checking instruments. Their stories change over time, becoming polished by repetition and softened by mercy. They do not always mention the worst fear. They speak instead of details, the smell of wet pavement, the way birds sounded before dawn, how the moon looked through thin clouds, how summer evenings seemed endless when no one knew they could be treasure. The final meaning of the thought experiment begins to come into focus. If another planet replaced Earth, the greatest lesson would not be that humans are weak, though we are fragile in many ways. It would be that habit hides dependence. On ordinary mornings, gravity feels like nothing. Air feels like nothing. The sky feels like background. Water arrives from a tap. Food appears under store lights. Seasons turn with enough reliability that calendars seem natural. The planet supports these miracles so steadily that they vanish from attention. Only when they change do we see them. Earth is not merely where life happens. It is an active partner in every breath, harvest, migration, shelter, and memory. Its gravity shapes bones and rivers. Its atmosphere makes weather and sound. Its magnetic field helps guard the upper air. Its rotation gives the rhythm of waking and sleep. Its moon moves the seas and lights the night. Its soils carry old life into new growth. Its oceans store warmth and move it around the globe. Its climate, unstable over deep time, but gentle enough during human civilization, allowed agriculture, cities, writing, science, and the long illusion that the ground beneath us was guaranteed. A replacement planet would reveal that habit was never ownership. Humans did not command Earth's conditions. We arose within them. Our bodies are written in Earth units. The curve of the spine, the strength of the heart, the timing of sleep, the chemistry of blood, the crops in fields, the shape of buildings, the routes of ships, the stories of the moon. All are responses to a planet so familiar it became invisible. To lose that familiarity would be to discover how much of being human is planetary. Yet the same scenario also reveals something resilient. Humans are not only adapted to conditions, they are also adapters of meaning. We build tools, shelters, calendars,
Maps, songs, laws, rituals, and explanations. We teach children how to survive realities we ourselves barely understand. We preserve memory in archives and recipes, in names and ceremonies, in the way we describe a color
that no longer fills the sky. We make homes out of repeated care. We learn the weather that frightens us. We turn measurement into trust, and trust into sleep. The cosmos, in this story, does not become kinder. It remains vast, indifferent, and mostly empty of human comfort. Planets are not designed around us. Habitability is not a promise. Even worlds that look beautiful from space may be crushing, freezing, airless, poisonous, unstable, or simply wrong for our particular form of life. The replacement planet is frightening because it is close enough to permit survival, but different enough to take away ease. It reminds us that the boundary between home and alien world can be made of small numbers, a little more gravity, a little less pressure, a longer day, a weaker shield, a changed ocean, a sky of another color. Over time, the new human settlements glow softly across the altered nights. From high above, they might look like constellations laid on the ground, clusters of light protected under domes, inside valleys, along coasts made cautious by unfamiliar tides. Around them, dark landscapes breathe under weather still being learned. Roads connect some places and fail before others. Greenhouses shine with steady artificial dawns. Water plants hum. Children sleep in rooms built by parents who were once afraid the first night would never end. Outside one settlement, perhaps many years after the replacement, a child stands with an adult at the edge of a covered observation deck. The air is safe for a short time. The wind is mild. The sky has deepened into evening colors that have no old Earth name. Above the horizon, the new moon, or the absence where the old moon should have been, shapes the silence. The adult looks upward and sees everything that was lost. Blue mornings, ordinary rain, familiar tides, the unthinking confidence of a world that fit. The child looks upward and sees the beginning of stars. Neither vision is wrong. One is memory, one is belonging. Between them is the narrow bridge on which humanity has always walked, carrying the past in one hand and the possible future in the other. The shelters settle into night. Air systems lower to a softer rhythm. In the greenhouse corridors, leaves turn slowly toward lamps that imitate a sun they did not evolve beneath. Water moves through pipes with a sound like distant rain. Somewhere, an old recording of Earth's ocean plays quietly for those who still need it. Somewhere else, real waves move under a changed moon, following equations older than sorrow, touching a shore whose people are finally learning when to step back and when to listen. The planet continues without needing to explain itself. It turns beneath the sun. It gathers heat and releases it. It pulls at bodies with its chosen gravity. It lifts weather over mountains, bends light through air, carries rivers toward basins, and writes new habits into every living thing that remains. Human beings sleep inside their careful rooms, surrounded by walls, filters, seeds, tools, memories, and one another. They are still fragile. They are still afraid sometimes, but they are also still here, and far beyond the covered windows, beyond the quiet settlements and the watchful instruments, the unfamiliar sky moves with patient calm. It is no longer Earth's sky. It may never become gentle in the way Earth once was, but night after night, as people breathe more slowly and children dream without comparing one world to another, it becomes something else. Not the world humanity was made for, perhaps, but the world where humanity learned, with sorrow and wonder, to remain.